Hi guys, if you could pull out your yellow review packet and your assignment from last night, I need a completion score out of 10 for your book assignment. Remember you had to do from page 143 and from page 152. I want you to take a minute to check your answers and you can pause me. If you have any questions that didn't get answered, I will definitely help you on Monday. And we are going to go into the third method of solving a system today. So if you could find the notes that I handed out yesterday. We're going to solve linear systems by graphing, by substitution, and then method number 3 is linear combination. And the basic idea is kind of like this. Let's say we know A is 11 and B is 3. It kind of works to add these equations together because if we took A plus B, that would be the same thing as if we did 11 plus 3. And if you agree to that, then you agree to the basic method we're going to use today. So if A is 11 and B is 3, then A plus B is 14. And that's kind of what we're going to do with our systems of equations. So instead of graphing or substituting, let's try just adding these two equations together. So we're going to get 2x and 3x makes 5x. 1y plus negative 1y makes no y's. And 9 plus 1 is 10. And you'll see that, maybe just by luck, but because these were opposite, we wound up with no y's. And that's a good thing because now when we divide by 5, 10 divided by 5 is 2. And we know what our x value is. We just go substitute that back in, either to the first one or the second one, doesn't really matter. Put the 2 in for the x, and figure out your y value. You can write that as x equals y equals, or you can write it as an ordered pair. Either way, that would be the solution to the system. Remember that you can plug it back in and make sure it works. If I plug in here and here, that would be 6 minus 5 is 1. I'm pretty convinced. So that's the method of linear combination. Sometimes linear combination is called elimination, and the reason it's called elimination is because that very first step, the y's got eliminated, and that's what allowed us to figure out the x. We're going to do a few more examples that aren't quite as easy. Let's try this one. If you look at this one, can you see ahead of time who's going to get canceled out when you add them together? It's the 3x and the negative 3x that cancel each other out. We would have 4y, and we'd have 28. Divide by 4, and this time we found the y first. Same process though, we're just going to stick that 7 back in one of the equations, does not matter which one. I got negative 2. If you're going to write as an ordered pair, be careful though that you get your x in the right spot and your y in the right spot. It never hurts to go back and check, plugging those back in. I'd have a 6 if I went here and a 21 here. That makes 21. I'm happy. The second example here, can you see how it's not going to work out if we just, let's just do it. If I try to add these together, I'm going to get 5x minus 1y equals 0. And I'm no closer to the solution than I was before because now I just have another equation with an x and a y. So that was, it was worth a shot, but it didn't work. We kind of want to set it up so we know something will be eliminated so that when we combine them together, it'll work. What I'm seeing is, well, at least this is a positive y and this is a negative y. If this was a positive 2 and that was a negative 2, I'd be happy. So one thing that's legal is to multiply both sides of an equation by the same number. That's a legal step. So I'm just going to rewrite this whole system, multiplying the top one by 2 on both sides. Once we get to there, now let's try adding those equations together. And it works way better, right? Because the y's are opposite of each other. We get 0 y's. Divide that 9 over, we get x equals 1. Throw it back into any equation you want, and you can get the y value. write it as an ordered pair or write it as an x equals y equals. Either one is okay. Always a good idea to plug it back in and make sure it works. Number 3 isn't even set up in the right format. We really need our x's lined up, our y's lined up, and our numbers lined up. So that's the first thing I'm going to do, is kind of rearrange. So I kind of feel like this 2x needs to come over, so I'll have to subtract 2x from both sides to make it look like this. And actually I'm loving this because do you see how the x's will eliminate each other? So I can go straight into adding them together. I got y is equal to 2. I go back in and sub into either equation. I got 5 for x and 2 for y. Uh-oh. Doesn't look like that works. What did I do wrong? I don't know. What did I do wrong? 10 minus 4. Oh, dear. Oh, I got it. I wish you guys were here to help me. That was supposed to be a negative 2. Sorry. So if this is a negative 2, oh, fail. Then this is a 6, and this is a 3. All better, Mrs. Backlund. I'm glad I checked it though, right? I only found that mistake because I went back and I was trying to see if it still works. So now if I plug in a 3, I get 3 minus 8 is, oh, there it is, a negative 2. I think I'm happy now. Oh, caught my mistake because I checked. Number 4. I'm thinking the x's won't cancel out, the y's won't cancel out, so I need to fix it up. And you can choose. Either we can make these x's opposite, or we can make the y's opposite. It will not matter which one we go for. To me, I'm kind of looking at it, maybe I want to make the x's opposite. If I want to make the x's opposite, I've got a 2x. If I could make that into a negative 2x, that would be cool. So I will multiply both sides by 2. And I'll just rewrite this whole thing. I've got 2x minus 4y. Now I've got negative 2x plus 4y. Make sure you remember to multiply both sides by 2. That's a common mistake. Now it looks like those x's are going to cancel out. I've got 2x plus negative 2x is nothing. Negative 4y plus 4y is nothing. And 20 plus is nothing. Now, it might seem like I made a mistake, but we saw this yesterday with substitution. Isn't that a true statement? 0 is equal to 0. 0 is always equal to 0, no matter what x's and y's we use in our equations. So this is just an indication that you've got infinitely many solutions. I'm going to start you out on the word problems today. In my brain, there's kind of 3 types of word problems that I'll be showing to you. And one of my favorites is the 2 totals type of word problem. So here it is. Corey bought some apples for 45 cents each and some bananas for 25 cents each. He got 13 pieces of fruit for $3.85. How many were apples and how many were bananas? And the idea is if you can find the 2 totals in the word problem, that tells us how we can set up 2 equations. And to me, I think the 13 is the total number of pieces of fruit, and the $3.85 is the total amount of money he spent. So when I set up a 2 totals system of equations, I'm going to have 2 equations. One of my totals is going to be 13, and one of my totals is going to be $3.85. One of the most important things when you're doing these word problems is to decide what your x and y are going to stand for. So on all of these, I want you to tell me what x and y you want them to stand for. Almost always, you just want them to stand for the thing you're looking for. So I want to know how many were apples and how many were bananas. So how about I make X the number of apples and Y the number of bananas. And then I can try to set up an equation. So remember that this 13 stands for pieces of fruit, and this 385 stands for dollars. So maybe I'll even write that there so I remember. When I add together the number of apples plus the number of bananas, am I going to get fruit or money? If I add apples and bananas, I get fruit. So that tells me that when I do my X plus Y, that's my 13. I need to come up with something about money for the second equation, and that's where the other info comes in, right? The apples are 45 cents. So 45 cents per apple plus 25 cents per banana would equal the total amount of money. So money plus money equals money, fruit plus fruit equals fruit. Here's a system that you could solve if you felt like it. I'm not going to go through solving it right now, but you'd have your choice of any of those three methods. And let's try just one more. Lindsey went to the nursery and bought 13 shrubs and 4 trees for $487. On another trip, she bought 6 shrubs, 2 trees for $232. How much does each shrub and tree cost? Do you see the two totals? Her two totals showed up on her 2 receipts. This time it's not an unknown what our total number of shrubs and trees is. The totals are those $2 amounts. So I'm just going to go ahead and put 487, 232, and this time both of those stand for dollars. Before you try bringing in a variable, you got to decide what your variable means. And this time they're asking me how much does each shrub and each tree cost. So how about we have X stand for the cost of a shrub, and Y could be the cost of a tree. I wouldn't want X to be the number of shrubs, because I don't care. They already told me the number. I want it to stand for what I don't know. So X is going to be how much each shrub costs. Alright, so this 487, that total came about from buying 13 shrubs. 13 shrubs would cost 13 times however much a shrub costs, plus 4 trees times however much a tree costs. 6 shrubs, that money, plus 2 trees, that money, equals my other bill, my money. This is the system of equations that we could solve. We could use graphing, we could use substitution, or we could use linear combination, the elimination method we just learned. I'm not going to go through how to solve it right now, but you can practice. I just wanted to kind of get you into the idea of how the two totals type of word problem works, and you're going to practice a couple in your homework. Your homework is all in the same section of your book today. Remember, I would like you to write A2.1 Day 2 at the top of your homework. These are the problems I'd like you to do. You shouldn't need any graph paper, I don't think. You might want to double check. Make sure you show all your work. It's not worth anything to me if all you have is answers. And go ahead and just leave it in your notebook, because I'm not even collecting it until next Friday. But I do expect it to be done on Monday for full credit. And you have the rest of the class period to work on it, help each other, and I'll see you Monday.